Question 2 of January 2025 S1 paper says, as part of an investigation, Bobby collects a sample of 47 observations. The results are shown in the following stem and leaf diagram where A is a constant. We are given a key that says that 3 line 2 means 0.32. In part A, we need to find the range of these observations. The range is the biggest value minus the smallest value. So in this case, the biggest value is 8 and 7, so 0.87 minus 2 and 1, which is 0.21, which gives us an answer of 0.66. In part B, we need to find the median value of these observations. So in order to find the place in which the median value is, we do 47 divided by 2, which is 23.5, but we round it up to give us 24. Now we need to find the 24th value. So it's a good idea to plot the cumulative frequency. So we have here 5, then 15, then 26, 32, 39, 44, 47. And we need to find the 24th value, so it's in this range here. So this is the 26th value, this is the 25th, and this is the 24th. So we get 0.48 for the median value. In part C, we are told that given that the interquartile range of these observations is 0.31, we need to find the value of A. The interquartile range is Q3 minus Q1. Q3 is the third quartile and Q1 is the first quartile. Q3 is the 75th percent of the samples and Q1 is the 25th percent. So we need to find Q3 and Q1. For Q3, we do 47 over 4 times 3. This gives us an answer of 35.25. Rounding it up, it gives us 36th value. So the 36th value is somewhere here. So this is 39, 38, 37, 36. So the Q3 is 0.6A. For Q1, we do 47 over 4, which gives us a value of 11.75, which is the 12th value. So we need to find the 12th value for the Q1. This is the 15th, 14th, 13th, 12th. So Q1 is 0.35. We know that the interquartile range is 0.31. So we say that 0.31 is equal to Q3 minus 0.35. So Q3 is equal to 0.66. So A is equal to 6. In part B, we are told that Bobby calculates the following statistics from these observations. And we need to show that the standard deviation of these observations is 0.176 to 3 significant figures. Standard deviation is given by all to the root of sx squared over n minus sx over n all to the squared. N is the number of samples, so in this case n is equal to 47. So now we just plug in the values that we found. So the standard deviation is equal to all to the root of sx squared, which we have here. So 13.4228 over n, which is 47, minus sx, which is 23.72 over n, which is 47, and all to the squared, 0.1755, which is equal to 0.176 to 3 significant figures. In part E, it says Bobby now collects 18 more observations from the same investigation. Using all 65 observations, the sample mean is 0.502 and the sample standard deviation is 0.204. we need to show that the sigma y is equal to 8.91. The new mean, which we know to be 0.502, is now equal to sum of all the x's plus sum of all the y over the new n, which is 65. We know the Sx, which is 23.72. Taking the 65 to the other side, we get a value of 32.63 is equal to 23.72 plus sigma y. Leaving sigma y alone, we get a value of 8.91 for y, which we needed to show, so hence shown. In part II, we need to calculate sigma y squared. We are given the standard deviation, which is 0.204. So the standard deviation, as we said before, is equal to all to the squared. In this case, is going to be sx squared plus sy squared over n minus the mean all to the square, which we found to be, which we're told that was 0.502. So 0.502 all to the square. That is the standard deviation. We're given the standard deviation to be 0.204. We're given the sx squared earlier to be 13.4228. And we need to find sy squared, sum of sy squared. And in this case is 65. And minus 0.502 squared. Rearranging that, we're going to get the value of sigma y squared. In order to get rid of that root, we square everything. So we're left with 0.041616 is equal to 13.4228 plus sigma y squared over 65 minus 0.502 squared. Taking the 0.502 squared to the other side, we're left with 0.29362 is equal to 13.4228 plus sigma y squared over 65. Taking the 65 to the other side, we're left with 19.0853 is equal to the above. And leaving sigma y squared alone, we get sigma y squared to be 5.6625. And to three significant figures, we get that sigma y squared is equal to 5.66.